there are two more normal forms, the fourth and the fifth normal form. And these continue to break down the data in order to eliminate redundancy, but they are rarely used in industry. You'll probably talk much more about the fourth and the fifth normal form in the CS course 2550, which will go over databases, but we're going to stop here. And we're going to talk about some pointers that you can use to make as efficient database as possible. As I said earlier, the database administrators get paid the big bucks in order to walk a fine line between how much space a database takes up and how fast I can return data from it. So some of the things that you can do to reach this balance is to try to decide how the data in your database is going to be used. Do you need first name and last name split out as two separate fields, or two separate fields, let's say for instance, that are 50 in length? Or can you combine them together into a single field that maybe is 65 in length? I'm saving space. It depends entirely upon what I'm going to do with the first name and last name field. Another one might be the address field. Can I just have one single address, 125 North Main Street, Layton, Utah, 84401? Or do I need them broken out into individual fields? Let's say, for instance, that I'm just going to be mailing something to my clients. Maybe I just need an address field. But if I am UPS or I'm FedEx that needs to be delivering, I'm probably going to need the street number broken out from the street name so that I can plot a route for delivering all my packages. I'm going to plot a route to 125 North Main, 185 North Main, 165 North Main, 215 North Main. So I'm probably going to need those fields broken out. So I should probably know how each piece of information or each field is going to be used. I'm probably going to want to make a master field list. And this is going to be the names of the fields and how they're going to be used, the type of data that's going to be stored. Is it just going to be a number, like my quantity is a number? Is it going to be a date, like my expiration date? Or it will be alphanumeric characters, like my store number? That is going to determine how it will be used and how much information needs to be stored. Also, I want to come up with the domain. What are the full set of possible values that that field might contain? Then we're going to group the tables together. I'm going to put fields and columns into my tables, and then the next thing I'm going to do is work on relationships. I have 3 tables that we have just created. My main table, my top ramen table. I have a store name table and a store zip code table. I need to define or understand what the relationship is between these 3 tables. They are related to one another. I can tell because in the main table, my store number is related to my zip code table by a primary key. A primary key in another table is actually called a foreign key. So in my store zip code table, the primary key is A3B. When I put that field or that primary key back into my original table, it's referred to as a primary key. So the different types of relationships that we'll find between multiple tables, the first one is called a one-to-one. A one-to-one relationship means that for one record in one table, there is one and only one record in another table. An example of a one-to-one relationship would be a database that contains a store manager table and then a store table. We're going to have one single manager for one single store, and one store is going to have one manager. So there would be a one-to-one relationship between those 2 tables. The next type of relationship would be called a one-to-many relationship. And a one-to-many relationship is what we have seen in our table so far. There is one record in my store zip code table, and there are many occurrences of, let's say, A3B, that primary key. There are many occurrences of that in my original table. This is a one-to-many relationship. And the last one that we'll talk about is a many-to-many relationship. A many-to-many relationship would indicate that there can be many occurrences of a record in one table and many occurrences of that record in the second table. An example of this might be that elementary school that we were talking about that has a student table that also has a parent table. So a student in the student table can have many parents, and a parent can have many students in that school. That would be an example of a many-to-many relationship. And in a relational database, many-to-many relationships are not an acceptable type of relationship, but you'll find out more about that when you take 2550. So once I've had a chance to identify all the fields that I'm going to be using and create a master list, and then generate the tables that I'm going to be using and move through the 3 steps of the normal form, And then finally, evaluate the relationships. The last thing that I want to do before actually filling it with millions and millions of records is just test it. I want to put in maybe 100 records, and I just want to test it to see if it is fits right together. I want to look for errors, because it's a whole lot easier to make changes to a table that contains 1,000 records than it is one that contains 10,000 or 1,000,000 records. So now that we have normalized our tables, we would create them in some kind of a database management tool, and finally we would create some queries so that I could pull some information out of them. And that's what we will be doing next.